Alright everybody, welcome back. This is part 2 of the video on systems of equations. In the last video above, Ms. Garcia talked to you about how you can decide if a point is a solution to a system by substituting it into each of the equations to see if it's true or not. Well, there's a second part of this is if we take a system of equations and we graph them, we can find the actual solution. So the way we're going to do that is that we're going to take, this is a system of equations because it's in a set. That means that these two are connected somehow. Maybe one has to do with the cost of running your business, and this is the profit your business makes. But somehow these two equations are connected, and we're going to graph them. Well, this first equation is already in slope-intercept form. That's y equals mx plus b. And so this is actually ready to graph. And so all I have to do now then is to graph it. That means I'm going to start with the b, which is the y-intercept. The y-intercept on this one is -3, so that means I'm starting at the origin, going down 1, 2, 3 to -3. There is my y-intercept. And then my move, why don't we say b is begin, m is move or slope. My slope, there's nothing in front of it, so it must be a 1, which means I'm going over 1, up 1. And I'm going to do that the whole way through the graph. And the reason why I do it the whole way through the graph, it's good practice, and it helps me build a nice straight line. So my line isn't crooked. The opposite of up 1, over 1 is down 1, -1, or -1, down 1. And we go all the way through. And there is my first line. And anything that falls on this line, any point that's on this line, is a solution to this one. So then, now we have to graph the second one. I'm going to pick a different color here, since Christmas has just happened. This is going to be green. So we're going to, again, y equals mx plus b. B is my begin. It says I'm going to begin at -1. Okay? And my slope, well, there's nothing here, so this must be a -1, and that means -1 over 1. That means I'm going over 1, down 1, over 1, down 1, over 1, down 1. And I go all the way through, again, to keep my line straight and for practice. Or the opposite is -1, up 1. And I go all the way through, and now I have my second line. And I'm going to graph it. And then it says, okay, what is the solution? Well, remember, for the red equation, anything on the red line is a solution. For the green equation, anything on the green line is a solution. So the only place that I have a solution for both is where they intersect, and that is right here. At this point right here where they intersect, that point is on the x-axis, because remember it's x and y is an ordered pair, is 1 for the x, and then down 2 for the y, so -2. So the solution to this system is 1, -2. Let's just really quickly go back though. If I had picked, for instance, this point here as my solution, well, this would be -1, -4. -1, -4 will work for the red equation because it is on the red line. But will it work for the green equation? And the answer is no, because it's not on the line. So this is sort of a visual representation of your equation. And so it's really easy to find the solution because you're looking for the point where the two lines intersect, and that point will be the solution. And we can go back and verify if we want to. We can go and put 1 and 4 on this first equation. If I replace the y and the x with parentheses and said x was 1 and y was -2, and let's see, 1 minus 3 is -2, and does -2 equal -2? Check. That means that this point is a solution for the red equation. And then I can go to the green equation, and again, parentheses for the y, and parentheses for the x. Notice I didn't put the negative sign in the parentheses because I just want parentheses for the x. And I'm going to go ahead and plug that, or substitute the values in again. My y was -2, and my x was 1. And now I have -1 minus 1 is -2, and does that equal -2? Check. So I won't do this every time, but if this was a test and I wanted to make sure I graphed something correctly, I might go back and substitute it in there just to verify that this is actually the solution. And as you see, it works for both, so this is the solution to this system. That's the last time I'm going to do that, though. From now on, I'm just going to graph it. So here's another one. So again, to find the solution to a system of equations, I can graph them and find out where they intersect, and that will be my solution. The problem is I go to graph this, and I'm like, uh-oh, this is not in slope-intercept form. Now, for those of you who've done standard form, you know that I can find the slope and the y-intercept from this in this form. And if you can do that, God bless you, you should do that. If you can't, let's talk about putting this in slope-intercept form. If we're putting it in slope-intercept form, that means I'm getting y alone. That means here's my y, and that makes this my constant, and my coefficient is 1, so I don't have to worry about that. And I'm just going to go, okay, to get y alone, I'm going to subtract x from both sides. And I'm going to go, that's 0, and I get y equals, x has always come before. And I can either leave it blank, or I can even put plus 0, because I'm about to graph it, so it's useful to have that 0 there, because that reminds me. So now this is in slope-intercept form, and the reason why I left if I didn't put that 0 there, I'd be going y equals mx plus b, and I'd be like, well, what's my b? Well, it's 0. So, where am I beginning this equation? Well, I'm going to make this equation the red equation. The red equation begins at 0, so my y-intercept is 0. And then my move, or my slope, is, there's nothing there, so this is going to be at a negative 1, because it's a 1 in front of it. That means that my move is negative 1 over 1, so I'm going over 1, down 1. I do it all the way through the graph to practice and to make sure my line's straight. Same way here. And boom. There's my first line, right? So anything that's on this line is a solution to this equation. Now I'm going to do the green equation, I'm going to call it, because I'm using a green pen next. This one's already in slope-intercept form, but again, I'm going to write above it y equals mx plus b, just to keep me on track. And say, okay, I begin with b. My begin, or my y-intercept is 1. That means I'm going from the origin up 1. And then my move, or my slope, is over 2, down 1. Down 1, over 2. And they don't intersect there, but the opposite of that is to go negative 2, up 1. Negative 2, up 1. And it's on the same line. And now I draw my lines, and boom. So again, anything on the green line is a solution to the green equation. So to find a solution to the system is I have to find a place where they intersect. Because at that point, anything that works for one will work for the other. And I can see right there is where my solution should be. So that ordered pair, that x and y value, is going to be negative 2, and then it's going up 2, so it's going to be negative 2, 2. So this negative 2, 2 is the solution to this system. And again, if I wanted to, I could actually go back into these two equations and check and make sure it works for both of them to make sure I've done it right. All right, moving on. Okay, you go ahead and try this really quickly, graph it on your paper. Hopefully you have graph paper. There should be a link on the home page to graph paper so that if you don't have it, you can link it and you can print it out, and so you have graph paper of your own to work on. So here we go. Now that you've done this problem, I hope, let's go straight to it. The first equation, again, this is a system of equation, and the first equation is y equals 1/3 x minus 3. It's in slope-intercept form. So I'm going to start at the beginning. Remember, y equals mx plus b. So my begin is at negative 3. So I go to negative 3. And my move is 1 over 3. So I'm going to go over 3, up 1, over 3, up 1, over 3, up 1. And negative 3, down 1. And again, for those of you who struggle a little bit with this was a positive 1/3. One of the many things you have at your disposal to help is, I know my slope is positive. Well, positive, negative, no slope, 0. This is a positive slope, so I'm pretty sure I probably graphed it right. And so there's my green line. Anything that is on this green line is a solution to this equation. Next, I will take down the next equation. The problem with this equation is it is not written in slope-intercept form. That means I need to get y alone. To do that, I have to treat this like a literal equation, where I'm going to circle the variable, underline the coefficient, which in this case is just 1, and double underline the constant. To solve it then, I'm going to go, okay, minus 2x to get rid of the positive 2x. That's 0, and I get left with y equals, and remember, x's go first, minus 2x plus 4. There's no coefficient, so I'm done. I can go straight into graphing, and remember, we know y equals mx plus b. It always helps me to kind of keep me going. That means my begin, or my y-intercept, starts at 4, so I start at the origin and go up 1, 2, 3, 4. And my slope is negative 2. Negative 2 as a fraction is negative 2 over 1, so I'm going to go over 1, down 2, over 1, down 2. And I'm going to keep doing that all the way down the equation. And I know some people get lazy. Oops, messed up right there. I know some people get lazy and say they stop or where it intersects, but I want to see the nice graph of this. The opposite of this is negative 1 up 2. And now I have the lines. I have arrows to show that it goes on forever in both directions. And now I say, where is the solution? Well, everything on the red line is the solution to the red line. Everything on the green line is the solution to the green line. And where they intersect is the solution to both equations. And this one intersects at, remember, x and y are my ordered pairs. So at x, 1, 2, 3, and at y, -2 is the solution. And again, if this was a test and I was worried about it, I could go back and substitute those values back into the original equation and make sure they work for both. And that way I would know I had done it right. All right, another one. Here we go. So, another systems of equations. The first one is y equals x plus 2. It's already in slope-intercept form, so this should be easy. And so I start with my begin or my y-intercept, and it says I'm starting at 2. Oh, did I pause? I hope I did. Start at 2, and then my slope is, well, how many x's do I have? I have 1, so my slope is 1 over 1, so I'm going over 1, up 1. And I do it all the way through my graph again, so I can keep my line straight. And some people ask, why do you do that, Mr. Craig? It seems like a waste of time. It's because some students will do this. They'll graph 1 point, 1 point, and 1 point, and then they'll do this. Is that a straight line? No. It's because they didn't have enough points to keep it straight, and it ends up looking all weird. So the way you keep your line straight is if you have you graph as many points as you can, it's kind of like connect the dots. It helps you keep your line straighter than it might be without those dots. All right, so there is my green line. Then I get to this one, I said, well, this is not in slope-intercept form, but that's okay because when we did graphing equations, we talked about special cases, and there are 2 special cases out there that exist. There's something called a hoy and a vux. A hoy and a vux. I always know vux because it sounds like I'm cursing. What the vux? So which one is this? Well, hoy has a y in it, right? And vux has an x in it. Which one does this have, a y or an x? Oh, it has the x, so this must be a vux. So then what does vux mean? Well, vux means vertical, undefined line, meaning no slope, at x equals. And what does x equal? At x equals -3, so at -3, I'm going to do a vertical, undefined, or no slope line. And there is my line. And you can see my graph, my line was a little bit crooked. You see how, because my line was just a little bit crooked, it doesn't look like they intersect the right spot? This is where we're talking about you have to be really accurate in your drawing. Some people even use rulers just to make sure, because even a little bit off can make you get confused about where the intersecting point is. And so again, the solution to this system is where the 2 lines intersect. Well, that's going to be right here, right? The ordered pair. Well, I already know that x has to be -3 because it's all the way up here, but again, ordered pairs are x and y. My x is at, -3. And my y looks like I'm down 1 at -1. And so again, if I wanted to check this, I'm going to plug these into both solutions and see if it works. Pause and try to graph it. Okay, here we go. So this problem right at the back starts off with, actually I want to see if I can drag this sucker down for you. Y equals -5. And because it's not in slope-intercept form, I already know it's a special case. We've already learned these special cases before. I asked myself, is this a hoy or a vux? And so I write them both down, hoy and vux. And vux has an x and hoy has a y. This has a y, so it must be a hoy. So hoy means a horizontal, zero slope line that starts on the y-axis. It starts on the y at -5. And so we go to -5. And 1, 2, 3, 4, 5. -5 is my y-intercept, and it's going to be a zero slope, so it's going to go straight across as y equals -5. And then that leads me to the second problem. The second problem, come on. The second problem is in standard form. Now, if you remember the standard form lesson where we did the opposite of A over B and C over B to find the y-intercept, then you're great. But if you didn't remember how to do that, then you're going to have to put this in slope-intercept form. To put this in slope-intercept form, we have to solve it like a literal equation, and y is our variable that we're solving for. That makes 4 or +4 our coefficient, and our constant is 5x. To get rid of the constant, we're going to subtract 5x. If we do it to one side, we have to do it to the other. This is 0, and that leaves me 4y equals -5x minus 20, because we always put our variables before our constants. And now, I have 4y equals negative 5x minus 20, but remember I still have that coefficient of 4, so I'm going to divide this side by 4. If I do it to one side, I have to do it to the other side. And so 4 divided by 4 is 1, which leaves me just y equals negative 5 divided by 4. Well, that's just going to give me a slope of negative 5 over 4x. But negative 20 divided by 4 I can do. That's going to be negative 5. So that gives me the equation y equals negative 5/4 x minus 5. And so if you remember, we said y equals mx plus b. b is my begin. I'm beginning at negative 5. Boom. And my slope is down 5 over 4. There's my first point. And I can go the opposite direction by going negative 4 up 1, 2, 3, 4, 5. Negative 4 up 1, 2, 3, 4, 5. And I can't get another one to fit on there, so this is as many as I can get, as points I can get in the graph. And then I just draw my line best I can. And oh, look at that. It intersects right here. Because both lines intersect here, this is on the green line and on the red line. This is the solution to the system. This is the point. Remember, x and y. My x is 0, and my y is negative 5. And so this is the answer, the solution to both systems. If you wanted to check it, you could go back in and substitute it into the original equation to see if you got it right. All right, go ahead and try the problems, and we'll be back with another video.